This lesson helps you understand square roots and radical expressions. You can understand square roots by starting with the square of a number. When you multiply a number by itself, you get the square of a number, which you can express as a power with an exponent of 2. So 2 squared is equal to 4. Notice, negative 2 squared is also equal to 4. So you can say 4 is the square of 2 because 4 is equal to 2 squared. You can also say 4 is the square of negative 2 because 4 is also equal to negative 2 squared. A square root is the opposite or inverse of a square. So you can turn it around and say 2 is the square root of 4 because 2 squared is equal to 4. And also, negative 2 is the square root of 4 because negative 2 squared is also equal to 4. Notice 4 has 2 square roots. In fact, every positive real number has 2 square roots. The symbol used to represent a square root is the radical sign. An expression with a radical sign is called a radical expression. The expression under the radical sign is called the radicand. So here's an expression for the positive square root of 4. Here's an expression for the negative square root of 4. You can use a plus or minus sign to combine the two expressions. So since 4 is a perfect square, the positive root of 4 is 2. And the negative root of 4 is negative 2. And here's the combined expression. So how about the square root of numbers that aren't perfect squares, like the square root of 5? Do these numbers exist? What kind of numbers are they? It turns out these numbers are real irrational numbers. The proof that these numbers are real is left for a later lesson, but it's easy to see they're irrational. Notice, the positive root of 4 is equal to 2, and the positive root of 9 is equal to 3. Assuming the number is real, the positive root of 5 would have to be a number between 2 and 3, such that the square of the number is equal to 5. If it was a rational number between 2 and 3, it would have to be a fraction. But you can't square a fraction and get an integer. For example, here's a fraction. When you square a fraction, you get another fraction. It can never be an integer. So, the positive root of 5 can't be a fraction, and therefore can't be rational. Numbers that are real and not rational are irrational. Irrational numbers are numbers that can't be represented by digits or numbers, so they're represented by symbols. In this case, the positive square root of 5 is represented by the radical symbol. So here's the positive square root of 5. Here's the negative square root of 5. And here's the combined statement. Plus or minus radical 5 is a way to write both roots in one expression. You can use a calculator to estimate the value of radical 5, which is about 2.23606. which you can round off to 2.2361. If you square this number, you get about 5.00014, which is very close to 5. However, no matter how many decimal places you use, you'll never get a number that's exactly equal to radical 5. And that's really what an irrational number is, a number that's real but can't be written down with digits or numbers. So 4 is a positive real number. It has 2 square roots. Because 4 is a perfect square, the roots are rational. 5 is a positive real number. It has 2 square roots. Because 5 is not a perfect square, the roots are irrational. 0 is a number that's neither positive nor negative. It has 1 square root. Negative 9 is a negative real number. It has no square roots, because you can't square a number and get a negative number. So these are examples of the kinds of questions you should be able to answer. Find the square root or roots of 16. The square roots of 16 are 4 and negative 4, because 4 squared equals 16, and negative 4 squared is also equal to 16. Find the square root or roots of 24. Because 24 is not a perfect square, the square roots of 24 are irrational, and they're represented by the expressions radical 24 and negative radical 24. Find the square root or roots of negative 25. Because negative 25 is a negative number, it has no real square roots. Actually, negative 25 has imaginary roots, but you'll learn about imaginary numbers in another course. You should also be able to simplify these radical expressions. Negative radical 16 equals negative 4, and radical 1 over 9 equals 1 over 3. You should be able to determine if these expressions are rational or irrational. Radical 81 is rational because 81 is a perfect square. And radical 11 is irrational because 11 is not a perfect square. And finally, you should be able to find the values of the variable that makes this expression real. Radical expressions are real when the radicand is greater than or equal to 0. So write and solve the inequality x minus 10 is greater than or equal to 0. You can solve this inequality by adding 10 to both sides. So the expression radical x minus 10 is real when x is greater than or equal to 10. This lesson helped you understand square roots and radical expressions. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.